Welcome to part 2 of Best Building Practices. This video will show the basic steps to build a robot using modular building, as well as cover the numerous advantages to building your robot using this type of build. Let's start off by looking at why modular building is so beneficial. First, it greatly reduces the time it takes to switch out between attachments during competition. Second, it maximizes the motor ports which are used. Third, it allows for multi-mission completion with just one attachment. And finally, it provides an excellent frame to build any attachment for any mission. The first step in designing your robot is to create a robot and sensor base. It is important to think through what sensors you are going to need for the specific challenge mat you are competing on. But in general, a gyro sensor, color sensors, and an ultrasonic sensor should work well for your robot and sensor base. Next, you must create a frame which fits around your robot. In this case, we create a square frame, which will make it easy to align the robot to walls at the edge of the mat. Once this is done, you must replicate your frame as many times as you need. In this case, we made 3. The next step is to attach your first frame to your robot. After this, you can build up each additional frame member you have made to create an entire cage for the robot. A useful piece for stacking the frames is this rectangular brace, which can easily connect each frame member to the next. This completes the base build for a modular built robot. Next, we will construct an outer cage, which will be slid over and used for attachments. To start this part, you must first create another frame that is 1 unit bigger in every direction. This will allow for the outer frame to slide perfectly over your base robot with no free spaces or gaps. Just like before, you must then duplicate the frame. This time, we only created 2. Next, connect these frames together, again using the rectangular pieces from before. It is important to also put stops on the outer cage to ensure it stays in place. At this point, you should be able to slide your outer cage over the base robot, where it will come to rest on the stops. From this build, you can now add any number of attachments to your outer frame and duplicate the entire outer frame as many times as you need. Next, we will go into some of the more specific features included on this robot that you may want to consider adding to your own. First, let's look at sensor placement on this robot. Notice how there are 2 color sensors and they are in the front of the robot. This gives you the ability to navigate by detecting color or contrast on either side of the robot. It is also helpful to surround your color sensors with guards made from beams, as you can see here, which will give you more consistent readings from your sensors by blocking out any ambient light or even shadows thrown by the robot itself. A gyro sensor has a tendency to drift when moved outside the horizontal plane. Because of this, it is helpful to center it within the robot between the wheels. This will stabilize the sensor for more accurate readings with less motion during startup and protect the sensor from being bumped since it's within the frame. Lastly, for the ultrasonic sensor, it is important to mount it where no parts of the robot will interfere with the front of the sensor, since this will produce false readings. Next, it is important to mount your medium motors in a strategic location so that any attachment can use them. For our design, they are mounted in the front corners of the robot, allowing attachments to be designed for the front of the robot. They are mounted so that the gear on the top of the motor is 1 unit up from the top of the frame, allowing interaction with the cage attachments that are placed on top. Knob gears are used for easy engagement of the gears when putting on attachments. Next, notice that the cages utilize 45-degree beams. This makes both the outer and inner frames asymmetric, so you cannot put them on backwards. The next feature we are going to outline is the square frame. This helps in 2 main areas. First, as previously mentioned, it helps for aligning your robot to walls in any orientation, front, side, or rear. And second, it helps to contain the sensor and motor wires on the robot, which is true of any square frame design. During any build, be sure that your charging port remains accessible, which will make it easy to charge your robot. For more information on port accessibility, check out our next video, Final Tidbits and Extras. Lastly, notice that the lowest frame secures the axles of the drive wheels. This provides another mounting location for the frame, as well as provides support on the outside of the wheels, which reduces flex in the axles of the drive wheels. These features are just some of the things you can include on your own design. Be creative and always make adjustments to any design based on different challenge mats and missions. Thank you for watching this video on modular building. For more guidance on good building practices, check out the next video, Best Building Practices Part 3, Final Tidbits and Extras. Also check out the programming videos using my blocks and button pushes for quick mission turnaround time.